Hello, and welcome to the first episode of a new series called ASP.NET from Scratch. My name is Jeremy McPeak, and I will introduce you to not only ASP.NET, but to the tools and technologies .NET developers use to write both Windows and web applications. Throughout the course of this series, we're going to build an ASP.NET application using web forms, which is a rather unique programming model Microsoft introduced with the first version of ASP.NET in January of 2002. And then we'll refactor that application using Microsoft's MVC framework, which was released earlier in 2009. In this first part of the series, we're going to download, install, and get comfortable with the free version of Visual Studio called Visual Web Developer Express. We'll also learn a little bit about web forms and where it comes from. So let's get started by downloading Visual Web Developer Express. So let's open up a browser window. And we're going to go to Microsoft.com/express. Now if you have Silverlight installed, you'll see something a little bit different here, but it'll be basically the same thing. We want to explore by product. And as you can see, there are several different versions of Express. There's a Visual Basic, Visual C#, and Visual C++. These three versions are primarily for Windows programming, so we're not going to worry too much with those. We do, however, want to choose Visual Web Developer, and we'll choose what language we want it in, and we'll click the download button. We'll choose Run, and Run again. Now my installation of Windows XP is essentially clean. I do have C# Express installed, so my installation of Visual Web Developer will take just a little bit less time than yours will. If you want to send information about your setup experiences to Microsoft, feel free to. I'm not. I'm going to accept the license terms. I'm also going to allow Visual Studio to download RSS feeds from MSDN. I'm going to uncheck Microsoft Silverlight Runtime just to save some download and installation time, but I'm going to keep Microsoft SQL Server because we're going to use that in later episodes. So we're just going to install now. And while this is installing, let's look at some of the reasons why you would want to use ASP.NET. These are the primary reasons why I switched from PHP to ASP.NET many years ago. First, ASP.NET is part of the .NET framework. And because of this, ASP.NET is a fully object-oriented programming environment with a huge class library called the Framework Class Library, or FCL. This library has just about everything you'd want in it, such as file and memory, input and output. You can also interface with a variety of databases. You can draw graphics, spawn threads to perform more work, request data from remote systems, use regular expressions, parse XML documents. The list just goes on. The FCL is huge, and it's the same class library available to Windows programmers. Because of this shared API, you can easily port your web application to a Windows application or vice versa. The primary difference between an ASP.NET application and a .NET application for Windows is the user interface. You can use your web application's business logic and data access layer in any Windows-based .NET application with ease. The only thing you'd have to recode is your UI. Second is what I call language independence, and this can be broken down into two parts. First, it doesn't matter what language you want to write an application in. You can use whatever language as long as there is a .NET compiler for it. Microsoft officially supports and has compilers for C#, Visual Basic, and C++. But you can find third-party compilers for other languages. For example, there's currently a PHP compiler called Phalange. You can also find information on upcoming compilers for Python and Ruby called IronPython and IronRuby. These two compilers rely on new features found in .NET 4.0, which is currently in beta. You can also find .NET compilers for more obscure languages, like if you're familiar with IBM's AS400 and iSeries systems, you can find .NET compilers for the RPG programming language, a language that was introduced in 1959. The second part of language independence is the ability to use libraries written in other languages. When you compile your code, the compiler compiles your code into an assembly. Now there are two different types of assemblies, and they are used to deploy your applications. The first type of assembly is an executable assembly, and they usually have an extension of exe. The The second type of assembly is a library assembly, and they typically have a DLL extension. All assemblies compiled by a .NET compiler can be used in any .NET application with little to no issues. For example, I could write a library in C# that parses RSS and Atom feeds. I can compile my library into a library assembly, and you can download and use it in an application that you are writing in Visual Basic. You can use it as if it was written in Visual Basic. It's completely transparent to you. Third, ASP.NET is fast because .NET applications are compiled. Not only are your code files compiled, but all files associated with ASP.NET are compiled as well. This includes the markup files, which are ASPX files, as well as ASCX files. .NET compilers generate what is called a Microsoft Intermediate Language, or MSIL. MSIL is what makes language independence work, because every .NET compiler takes your code and converts it to MSIL. The MSIL generated by the compiler is already optimized. The only way to optimize it further is to optimize your own code. So you don't have to purchase any third-party tool to optimize the MSIL. Of course, as with any platform, ASP.NET does have its faults. Perhaps the largest is the learning curve associated with it, primarily due to the object-oriented nature of the .NET framework. ASP.NET is fully object-oriented, so you'll more than likely have some trouble wrapping your head around ASP.NET if you don't already have a background in object-oriented programming. But there are online resources freely available to anyone wanting to learn the .NET framework. So you wouldn't be totally alone if you choose to take on the challenge of learning the .NET framework. The .NET framework is also designed for statically typed languages, as opposed to dynamic languages like PHP, JavaScript, and Python. This only adds to the learning curve, as you cannot declare a variable and assign it any value you want. With statically typed languages, you have to declare the variable and its type, and you can only assign values of that type to the variable. So you cannot assign a string value to an integer variable unless if you convert the string first. In .NET 4.0, this will change with the introduction of the Dynamic Language Runtime, or DLR, which is what the Iron Ruby and Iron Python compilers will use to compile the Ruby and Python languages into MSIL. There's also work being done to convert Phalange, the .NET compiler for PHP, to use the DLR as well. With the addition of the DLR to the .NET framework, we'll see many new compilers for many dynamic languages. By choosing ASP.NET, you are essentially limiting yourself to the Windows platform. Microsoft has released trimmed-down versions of the .NET framework for multiple platforms via Silverlight, but they do not have officially supported the .NET runtimes on any platform other than Windows. Now, there are open source projects to bring .NET to Linux with the Mono project, but it lags behind in support for newer .NET features. As a result of the limited platform availability, you can expect to pay more for ASP.NET hosting than you would for PHP, Python, or any other language. My installation of Visual Web Developer is finished, so now I want to give you some background on web forms and where they come from, because we're going to look at web forms first before we look at MVC in a later episode. Web forms came about because prior to .NET's release in 2002, there was a huge disconnect between writing Windows applications and writing web applications with classic ASP. At the time, the majority of programmers writing applications for Windows were using Visual Basic, and these VB programmers were using visual tools called Rapid Application Development Tools to aid them in developing their applications. VB developers were able to design their windows, which are called forms, by dragging and dropping UI elements, called controls, onto their form. They could then position and size the controls and wire up events to execute code when the user causes an event to fire. The application's code was completely separate from the UI's code. This is in stark contrast to writing a classic ASP web application, and if you're familiar with PHP, then you at least know how classic ASP applications were written because they are both similar in that respect. VBScript or JScript code was interspersed throughout HTML markup, and poorly designed web applications were a pain to maintain. So VB developers had a hard time getting a grasp of writing classic ASP applications because it was completely different than writing Windows applications. Well, Microsoft saw this, and they wanted to make web development more along the lines of Windows development for VB developers so that they could be brought into web development. Alright, now let's look at Visual Web Developer since we have all the introductory stuff out of the way. Now, Visual Web Developer is a version of Visual Studio, as are all the other Express editions. And because of that, you can expect a certain amount of features that Visual Studio offers. One such feature is this Start page. In the upper left corner is the Recent Projects box. When you create or open a project, it adds a link to that project in this box. As you can see here, I have a link called Web Application 1. If I were to click that, then it would open that project for me. This is a nice little feature that enables you to get into a project that you spend a lot of time in. It's a lot faster than going to the File menu and browsing for a project or going to the Recent Projects menu item. Underneath the Recent Projects box is the Getting Started box. And it contains some informational links for our specific version of Visual Studio. As you can see, there's some links for Visual Web Developer, as are for ASP.NET in general. Beneath that is the Headlines box, and despite its name of Visual Web Developer Headlines, these headlines are more generic and for pretty much any version of Visual Studio. As you can see, the first few headlines are for Visual Studio 2010, and in fact you'd have to go pretty deep in order to find some headlines specific to Visual Web Developer or ASP.NET. Finally is this large section which pulls an RSS feed from Microsoft's Developer Network site called MSDN. If you remember, during the installation we told Visual Web Developer that it can pull RSS feeds from MSDN, and this is a feed specific to Visual Web Developer. So let's create our first ASP.NET website, and we can do so in one of two ways. How we create our website determines how we deploy it later on. The first way is to go to the File menu and then choose the New Website menu option. We would select ASP.NET Website, which is selected by default. We would then select where we wanted to save our website, either on the file system, an HTTP server, or an FTP server. We would then choose what language we wanted to program our application in, and that can be either Visual Basic or Visual C#. Now, we're not going to create our website in this way because it's inefficient to do so. Whenever we deploy it to a server, we would have to upload not only our user interface files, which are all of our HTML files, our ASPX files, JavaScript and CSS files, but we also have to upload our C# code files. And whenever the user first requests our application, if it isn't compiled, then ASP.NET has to compile our application first, and it has to compile everything, all of the ASPX pages and all of our code files. So we're actually making the web server perform more work if we choose to create our website in this way. Instead, we're going to go to the File menu and choose New Project. We're going to select the Web subsection under Visual C#, and we're going to select ASP.NET Web Application. Now, our first application is going to be a one-page application, and it's going to have a form that will allow people to send us an email. So we're going to name our project Email Form. We're going to leave everything else default, and then we're going to click OK. Now, since we're creating this project, we'll be able to pre-compile all of our code files so that whenever we upload our application to the web server, all we have to upload are the user interface files, which are again the ASPX pages, any JavaScript or CSS or HTML pages, and then all we'd have to do is upload a DLL file. So instead of having to upload all of our code files and let the web server compile it for us, we compile our code first, and then we just upload the assembly that the compiler generated. Now, whenever you open or create a new project, you're going to see something similar to this. This is the default user interface of pretty much any version of Visual Studio. I'm going to go ahead and close this start page here. Now we're not going to go over every portion of the user interface because it's going to take a lot of time to do so. Instead, we're just going to look at the things that we need to look at whenever we need to look at it. So we're going to look at a few things within the Solution Explorer, within the Properties window, and our toolbox over here. This main section here is where we're going to do most of our work. It is a source code editor. It is also a designer. And we can choose a split view if we wanted to do that. We're going to spend just a little bit of time in the designer because I want you to see how web forms was actually created for Visual Basic developers. But for the most part, we're going to spend most of our time in source view. Now this file that is open here is our user interface file. As you can see, it contains HTML markup. There's also some special stuff for ASP.NET. But this is our user interface file. We can add any HTML elements that we wanted to. We could add some ASP.NET controls as well. We can also add some C# code, but we don't want to do that because the whole idea behind web forms is to separate the user interface from our back-end code. So whenever we want to add some C# code, we're going to actually go to a different file, which is called our code behind file. We're going to go to the Solution Explorer. We're going to click on the plus next to default.aspx, and we're going to double click on this default.aspx.cs file. And this is our code behind file. This is a pure C# code file, and we're actually creating a class here called _default, and it is inheriting from system.web.ui.page. Now whenever we create a new web page or a new web form, we're actually creating a class. So whenever we add any type of control, we're actually adding those things as a property to this class. So we can go back to our user interface file and we can look at this top line here, this directive. Now this is telling ASP.NET that this is a page, that it is written in C#. We have a code behind file, and we're telling the compiler what that code behind file is, and then we are also telling the compiler that this particular page inherits email form ._default. So if we go back to our code file, we're in the namespace of email form, and we have a class called _default. So let's go into design view, and we are going to add a control to our web form here. We're going to mouse over the toolbox, and this little flyout menu will show up. This will list all of the controls that we can add to our web form, and as you can see, there's quite a few controls we can choose from. We are going to add a label here, and we're just going to drag and drop it. And the designer automatically selects the control that we had just dropped. As you can see, it says label. And up here at the top it is saying ASP:label, and then it has a £sign and then label 1. What this is saying is that this is a label control, and we'll see this ASP:label again later whenever we look at the source code. And then the £sign along with label 1 is saying that this has an ID of label 1. Now a control is two things. First, it is a class. So we have actually created an instance of a class. And if we go over here to the properties, right under the properties, title bar is a little drop down box, and we can choose all of the elements that are in our web form right now. So we're going to choose label 1, which is the label that we just added. This is its ID, and this is how we refer to it within our code. This also tells us that it is an instance of the system.web.ui.webcontrols.label class, and that is a mouthful, but most of the controls reside within the system.web.ui.webcontrols namespace. Now the second thing a control is that it encapsulates one or more HTML elements. And as we change the properties of this particular class, then ASP.NET will change how the HTML is generated for this particular control. We're going to see that a lot more later on, especially whenever we start adding more controls and we start changing a lot of the properties. Now one thing that we do want to change here we're going to change two properties, and we're going to do so using the properties window here. We're going to go and scroll all the way down, and we're going to choose this ID within parentheses. This is the identification for this particular object, and right now it's set to label 1. We're going to change it to LBL name. This is going to be a label for the name text box. Our application will have 3 text boxes. It will have a text box for the user to enter their name, one to enter their email, and then one for their message. So this is going to be the label for the name text box. So we're going to name it LBL name, and then we are going to change the text property. It's right now set as label, which is what you see here. The text property is what is displayed to the user. So since this is the label for the name text box, we're just going to simply type name and press enter. And as you can see in the designer, the text changed from label to name. Now let's go back to this ID here. Within Windows Forms and Web Forms programming, the general convention is to name your controls with the first part of the name being a shortened version of the type of control. So since this is a label, we have used the name LBL and then name. If we were going to add a text box, the general convention is TXT and then whatever name that we want after it. This will enable us to find the controls easily, and especially whenever we have more than one control and we want to access them, we don't have to remember, oh, what did I name this control? If we know what type of control it is, we can at least start typing the abbreviation, and then the IntelliSense will give us a list of what the names of the controls of that particular control type are. Now we're going to go to our source view, and we're going to look at what the designer actually generated for us. It created what is essentially an element here. It is an element that has a prefix of ASP. It has a tag name of label. It has an ID of label name, which is what we actually set over here in the properties window. We have a run at server, which we'll go over here in a bit, and then we have a text property which is set to name. Now the run at server is something for ASP.NET. This particular attribute never makes it to the browser, but this informs ASP.NET of what is a control within our user interface. So whenever ASP.NET sees this particular form element, it knows that it needs to make this form element available to us, so that if we wanted to write code for this particular form, we could. The same can be said for this head element. ASP.NET will again see the run at attribute, and it will make the head available to us within our code. So since we can access these elements within our code, let's go to our code behind file, and we're just going to type L. Now this window here is called the IntelliSense window, and what Visual Studio tries to do is it tries to take our keystrokes and then it tries to determine what it is that we are trying to type. Since I typed an L, and since I have a control called LBL name, it automatically positioned to LBL name. Now I can double click this, or I can just hit enter, and it will finish it out for me. I'm going to hit period, which is the operator to get to the properties and methods of a particular object. And let's say I want to change the text property again, so I'm going to hit T, and as you can see, it positioned me into the beginnings of the T. I'm going to type E. We can see text, but we can keep typing, and as we type X, then Visual Studio will drop us down to text. And then we're just going to complete this statement. And let's run this. I'm going to hit F5. F5 is universal across all versions of Visual Studio. It runs your application in debugging mode. And as you can see right here, it's asking if we want to add a setting to our web.config file, which is a file that contains all the configuration settings for our application. If we want to set a setting to enable debugging, we want to do that because debugging mode adds a lot of extra information if an error is reached within our code, so that we can see some pretty detailed information about what caused that error. So we're going to click OK. Internet Explorer is going to start up. There is a built-in development web server with Visual Web Developer as well as Visual Studio. And as you can see here, this is telling us that we have an ASP.NET development server, and it tells us what port that it's operating on. The server is called Cassini, and even though it is a trimmed down web server, it at least gives us an opportunity to test our application before we deploy it onto a live web server. Now I'm going to right click and choose View Source, and you can see that ASP.NET generated a span element for our label. It gave it an ID value of LBL name, and it placed the text Hello World in between the opening and closing span tags. Now even though we originally set the control to have a text property set to name, in our code file we actually added this line of code within the page load event. So whenever the page loads, the control is already there and in memory. So it's there for us to change, and we did so here by setting its text property to Hello World. Now I'm going to add a new control here. Even though I'm still in debugging mode, I can add things to our user interface file. I cannot, however, add things to our code behind file. In fact, I'm going to press the Enter key, and it's going to tell us that we cannot make changes while the code is running, which is just fine. We don't need that right now. So I added a div element, and I'm going to add a text box control. And as you can see, as I type, Visual Studio's IntelliSense starts prompting me for every keystroke that I make. Text box is now selected, so I'm just going to hit Enter. I am going to press space, and IntelliSense is prompting me to add an attribute to this particular control. I want ID, and I'm going to give it an ID of txt name. I also need the runAt attribute. And then I'm going to close the element. Now I want to add one attribute here, and I want to add this associated control ID. I'm going to double click that, and I'm going to set it to txt name. So this is telling ASP.NET that I want this label control associated with whatever control has this ID here, which is this text box. So I'm going to go back to Internet Explorer. I'm going to refresh the page, and you can see that we now have a text box added to our page here. I'm going to right click and choose View Source, and we can see that our label control is now a label element. So since we added this one little property here, this associated control ID, ASP.NET saw that we wanted our label associated with the text box, so it generated a label element, and it set its for attribute to txt name, and we still have an ID of LBL name. The text box control generated an input element with a name and an ID set to txt name, and then its type attribute is set to text. So I'm going to exit debugging mode. I'm going to do so by just closing out Internet Explorer. Now even though we've exited debugging mode, our development server is still running. We could right click and choose to stop it if we wanted to. I'm going to leave this running because any other time that we run our application, it's going to use the same server. And since it's already running, it doesn't have to run a new instance of the server, so we're just going to leave it running. Whenever you compile your code, which we actually did whenever we ran it in debugging mode, the output window appears and it shows all of the output of the compiler. So we can see here that it was pulling a bunch of files from .NET files actually. This GAC stands for Global Assembly Cache. So it was pulling all of these files from the GAC. These are all files that are installed on our computer, and these are all files that are installed on any computer with .NET 3.5 Service Pack 1 installed. We can close out of that. Now, if there was an error in our code, which I'm going to make a deliberate error here, I'm going to take off this semicolon and I'm going to save it. Now, Visual Studio sees that there's an error here because in C# every statement has to end with a semicolon. So Visual Studio added a little squiggly line where the semicolon was. If we move our mouse over it, it says that a semicolon is expected. Now I'm going to go ahead and attempt to run this. The compiler is telling me that there were build errors, and it asks if I want to use the last successful build. I want to say no, and it's going to pull up the error list here, and we have an error saying that a semicolon is expected in the file default.aspx.cx on line 14, column 43. Now I'm going to go back to our interface file just so that you can see this a little better. I'm going to double click on this item here, and it takes me to wherever this error is. So I can fix it. Whenever I do fix it, then the error is gone out of the error window. And I'll save it, run it, and everything will of course run fine. So let's exit debugging mode. Let's also close the output window. Let's go to our code behind and let's get rid of this line of code. Now we have a text box control so that the user can enter their name, and we have a label control for that text box. So now we need to add similar controls so that the user can enter in their email address. And we can add these controls in a variety of ways. First, we can type them, but that can take a while, especially since we have many properties that we need to populate. We could go to the toolbox. We could find whatever control that we wanted to add, and we can just drop it in. As you can see, Visual Studio added in an ASP label element. It provided the ID, run at, and text attributes. But this too can take just a little bit of time. Nothing can really beat replication as copy and paste. And Visual Studio is actually pretty smart when it comes to copying and pasting. Like HTML elements, ASP.NET controls have to have a unique ID. Otherwise, ASP.NET wouldn't know what control that we wanted to access. So if we had two labels that had an ID of LBL name, ASP.NET would get kind of confused at what we were wanting to access. And in fact, it would throw an error whenever it saw that we had two controls with the same ID. So whenever we pasted, Visual Studio saw that we already had a label control with an ID of LBL name, so it just renamed our pasted label control label 1. It did something similar with the text box. It saw that we had a control with the name of txt name, so it just simply named this control text box 1. Now we're going to call this text email. So we're going to go ahead and use that as the associated control ID for this label. We're going to change this label's ID to LBL email, and we're going to change the text property to email. So we're going to run this just so that we can see it. We have two text boxes. When we click on the name label, it gives focus to the name text box. When we click on the email label, it gives focus to the email text box. Now the text box control, as we have seen, generates an input element. But we can actually use the text box to generate a text area as well. So I'm going to copy and paste this again. We're going to change this text ID to text message, and we'll set the associated control ID. We'll change the ID of the label to LBL message, and we'll change the text to message. Now we're going to add a property to the text box here. It's going to be text mode. And as you can see, there are 3 valid values for text mode. There's multi-line, which will generate a text area. There's password, which will generate an input element with a type of password. And then the single line is the default, which is an input element with its type set as text. So we're going to change this to multi-line. And we'll run it again just to make sure. And there we have a text area. There's also another property that we can add to the text box, and it is rows. We're going to set it to 20. So now all we need to add is a button. We're going to add another div element, and we're going to put a button control. We're going to give it an ID of btn submit. It's going to run at the server, and we're going to set the text property as submit message. So we'll run this so that we can see it. We now have name, email, and message text boxes so that the user can enter their name and their email address and their message that they want to send to us. Whenever they're done typing their message, they can click the submit message. But as you can see, whenever we click the button, nothing happens. So we need to wire up the click event for this button. Now I need to make an important distinction here. I've used the terms properties and attributes interchangeably, and it's kind of incorrect to do so. The reason being is that ASP.NET controls have properties. They don't have attributes. In fact, the only attribute that an ASP.NET control has is this runAt attribute. Everything else is a property. So you wouldn't set HTML attributes for an ASP.NET control. Instead, you would use that control's properties to generate the desired HTML attributes. To give you an idea of this, we're going to wire up the click event for this button. Now we're just going to double click on the button, and it's going to automatically generate a method called btn submit _ click inside of our code behind file. Now this method here is executed whenever the user clicks on the button, and this is server-side code. The user doesn't see what happens here. Let's go back to our user interface file. We're going to view the source, and we're going to see that an onClick property was added to our control here. This is not the onClick attribute that you may be familiar with within HTML elements. This does not execute JavaScript code. Instead, you would have to use the onClientClick property if you wanted to add some JavaScript code to execute. And we're going to do that now. We're adding in a call to alert, and it's just going to alert a simple string. And we'll click the button, and we see an alert box. We'll click OK. So let's exit debugging mode. So it's important to remember that even though there may be a property with the same name of an HTML attribute, chances are that does not do the same thing as you would expect it to. This onClick executes server-side code. This onClientClick executes client code. We're going to get rid of the onClientClick property because we really don't need it. And we're going to add a style sheet to our project. Now I have one pre-made, so I'm going to right-click on our project. I'm going to go to Add and then Existing Item. The style sheet I have made is called style.css, so I'm going to double-click that to add it to our project. Then all I have to do to add it to our page is to simply drag and drop it in. Now I'm going to open it up so that you can see the CSS editor for Visual Studio. Over on the left-hand side, we see all the elements that are listed here, and we can click on these to get to them quickly. We can also look at all the classes if they were listed here. Now I do have one class called cls-text-input, which we are going to use for the text box controls. However, since it's also coupled with an element, it is appearing underneath the elements section. Otherwise, if we took out the text area, you would see that it would then be added to the classes. But we are going to close out of that there. So since we have a class to add to our text boxes, let's go ahead and add it. Now, as I said earlier, controls have properties, and you can't really use HTML attributes within a control. And that's true here. If we press space and if we look at the IntelliSense, if we type class, we'll see that there is no class listed here. However, there is a CSS class. So we're going to double click that. And the IntelliSense is prompting us to add the CLS-text-input class because that's the only class within our style sheet. So we can just simply copy and paste. And all of our text boxes except our multi-line text box has this class. So let's run it and let's see what that did. It added a little bit of style to the text boxes, and they all match as far as width and colors. So we'll close. Now we're almost done here. We have a user interface that allows the user to input their information, but we're not doing anything whenever they click the submit button. So we need to add some code that will gather the information from the form, put it into an email message, and then send that email message to us. So we are going to go to our code behind file, and we are going to add code to the btn submit _ click method here, the event handler for the button's click event. Now we're going to use two classes here. The first is mail message. It resides within the system.net.mail namespace. You can see mail message here in the IntelliSense. The second class we're going to use is SMTP client, which is listed here. Now in order to use these classes, we have to reference the system.net.mail namespace. Let me finish out this statement here. I'm going to create an email object of type mail message. Now as you can see, I had to add in the system.net.mail namespace before I could even get to the mail message class. This can get a little long and redundant, especially if we're dealing with multiple classes within the same namespace. In order to help with this, we're going to add a using statement to the top of our code file, where you can see several other using statements. What these statements actually tell Visual Studio in the compiler is that we want to use the classes within these namespaces, but we don't want to type these namespaces more than once. So we are going to add a using statement for system.net.mail, and then that will allow us to remove the namespace from our code. Now we need to add some properties to our email message. The first is a subject. So we're going to type the object name and then a period and then subject. Now we didn't give the user the ability to set a subject, so we are just going to set one for ourselves. It's going to say email from email form. Now this is actually the long way of assigning properties, and it can get rather redundant as well because for every property we have to prefix it with the object and then a period. I'm going to just simply cut that out. With .NET 3.5, Microsoft introduced a shorthand version of this. Instead of simply just calling the constructor, we're going to call the constructor, then we're going to add an open curly brace, and then we are going to add the subject property. We're going to set it equal, and then I'm going to paste what I just cut, email from email form. I'm going to take out the semicolon and add a comma because we're actually listing the properties that we want to populate here. The second property that we are going to set is the body property. This is the body of the email that we will receive. And the user did provide us this information, and it was added into the text box with an ID of txt message. So we're going to get that information by accessing that control. and then accessing the text property. The text property gets and sets whatever is inside of the text box. We're going to go to the next property, which is called isBodyHTML. This is a true or false value. If it's set to true, then the body of the email will be in HTML. If it's set to false, then the body is going to be in plain text. We're going to set it to false. Now the last property that we're going to set here is the from property. And as you can see from the IntelliSense, this little tooltip comes up. It is first telling us that this property is of type mail address. Let's bring that back up here. This also tells us that it gets or sets the from address for this email message. So this is supposed to be an object of type mail address. And if you remember from earlier, .NET 3.5 is statically typed, so we can't just assign it a string, or else the compiler will throw us an error. So we're going to actually have to create a mail address object, but that's as simple as using the new keyword. Since from is of type mail address, IntelliSense is automatically prompting us to use the mail address class. And we're going to call a constructor. And as we can see here, there are 3 overloads for this constructor. If you're not familiar with object-oriented programming, an overload is simply just another version of that type of method. In this case, this constructor has 3 different constructors. It still creates the same mail address object, but we can create it in 3 different ways. The first way is we can provide it a string address. We can provide it a string address and a string display name. Or the third overload allows us to add a string address, a string display name, and then we could use a type of encoding if we wanted to. We're going to use the second overload here. So we need to add the address. The user gave us their email address with the text box control called txt_email. So we are going to access that control. We are going to get its text property. The user also gave us their name with the txt_name control. And we too will use the text property. So now we have created a mail address object, and we are assigning it to the from property. This is all that we are going to populate here within this shorthand version. So we're going to close it with an ending curly brace and then a semicolon. Now we need to add our email address because right now the email is not going anywhere. So we are going to access the email object. There is a to property, and as you can see, the IntelliSense is telling us that the to property is of type mail address collection. Now if you're not familiar with collections, you can think of it as an array. It's a little bit more technical than that, but an array will suffice for now. Well, most collections in .NET have an add method. This one does as well. And we have several different overloads here as well. We can create another mail address object and pass it to the add method, or we can simply just use our email address as a string value. Let's use the first overload, which is creating another mail address object. So we are going to type new and then mail address. Now I'm going to input my email address is ASP.NET from.scratch.sample. I created this specifically for, wow, I cannot type, specifically for this example here, and I am also going to put my name. Now feel free to put your own email address and your own name if you want to. We're going to make sure the parentheses match up because we have 2 here, so we want to close 2 parentheses here. So we have added a mail to address, and now we just need to send it. So we are going to create an SMTP client object. We're going to call it server. And then we are going to use the send method of the SMTP client class. We're going to pass it the email message, and that will send our email message. Now we could run this code and attempt to send ourselves an email, but it's not going to work. Our SMTP client object has to connect to an SMTP server in order to send our email message. That means we have to provide this object some information about our server, such as its host name or IP address. We also have to provide the port number as well as some user credentials, because we'll have to authenticate a user before we can send an email message. Now we could assign the properties of this object to contain this information, but doing so can potentially leak this sensitive information to the end user. If you forget to turn off debugging mode in the web.config file and an error occurs when our application attempts to send the email, the error message displayed to the user could contain that sensitive information. That would definitely be a bad thing. So instead of putting that information in our code, we're going to add it to the web.config file. That's where this type of information belongs anyway. So now I'm going to open our web.config file. I'm going to go to the Solution Explorer and double click on web.config. As you can see, this file is an XML file, and all of these elements were generated by Visual Studio when it created our project. Two elements of note are this app settings element and this connection strings element. If we have some basic settings that we want to set for our application and access within our code, we would set them within the app settings element. If we were going to connect to a database server, we would put its connection string inside the connection strings element. Now we are going to add an element called system.net, and as you can see, IntelliSense works even here. Whenever you type the opening tag of an element and you hit the closing bracket, Visual Studio will automatically add in the closing tag for that element. So inside system.net, we are going to add a mail settings element. Inside that, we'll add an SMTP element, and then we'll add a network element. Now there are several attributes for the network element that are for the information of our SMTP server. First is the port, which of course is the server's port number. Next is the host, which can be either the server's host name or IP address. Then is the username, which is of course your user's name for the SMTP server, and then the password. Now I'm going to leave these blank for security reasons, but we'll close out of this and we're going to run it. Now off screen, I went back into my web.config file and I added the information for my SMTP server. So whenever I click the submit message button, it'll send the email and we'll look at the email whenever it gets into my inbox. So for my name, I'm going to put ASP.NET from scratch, my email address, and the message is going to be hello from the email form application. Now before I click the submit message button, I'm going to go ahead and go to Gmail so that we can see that I have an empty inbox. I'm going to go back to the application and click the submit button. Now it looks like that nothing happened here, but if we go back to my inbox, we'll see that we have a new message waiting. Its subject line is email from email form, which is what we hard-coded into our application. It came from ASP.NET from scratch, and the email address is asp.net.from.scratch@gmail.com, and then the text of the message is hello from the email form application. Now we're going to stop here for this episode, and we'll pick back up where we left off in the next time. We'll add some usability to the email form because we need to tell the user if an email message was sent successfully or if it failed. I apologize for the length of this episode. We had a lot of ground to cover, and I hope it gave you an idea of what programming a web forms application is like. If anything wasn't clear, or if you have any questions, feel free to leave them in the comments. Thanks for watching, and I'll see you next time.